Today we're making the real looking Iron Man Arc Reactor. So it's so lightweight and thin that I can actually just stick it to my chest with just a little strip of duct tape. So it looks pretty comic accurate, and it's bright enough to shine right through a hoodie. Plus, it just runs off of a little 9-volt battery that just sits here in my pocket. So you don't even see the wire or anything, and it looks really nice. If you want all the parts for this, just check out the Patreon in the link below. I'll actually gift these out at certain donation tiers, and I'll just ship them to you, so you can make it yourself. But let's get right to the build. We're gonna start with building the 3D printed part of it. So that's gonna be this guy, assembling these parts. None of these have been finished yet or sanded, so they're just straight off my printer, so they're gonna have some strings and things, but I'll just pull them off as long as I go. I tuned the printer pretty well for this particular filament, so I think it does pretty good. First thing is we're going to have the left and right sides of each one of these rings. There's only one way they can go because we have the bevel here. It snaps right over that because there's a groove in the female that allows it to fit over to that. So there's the first one. Just gonna do that 9 more times around the part. That's what it should look like once you have all of those on. Now they're not glued or anything, they're just sitting on here. But once I wrap wire around it, that should hold them on just fine without any extra hot glue. The next thing we're going to do is line up the jig. So this is going to help us align the LEDs properly, because the SMD, surface mount LEDs, can be a little bit hard to wire because they'll slide around, they're kind of small. So we drop the LEDs in here and then they're easy to wire up, and then it makes sure that they're centered right behind the clear part. So line it up like this, where the divot comes down and lines up with the connection part of the clear part. Just like that. I'm just gonna put a dab of hot glue, one on either side, because it's gonna be held on once I wrap the wire around each one of those coil rings. This will be able to hold it in place while I do that. So this is gonna be your base, the ring that has 2 rings in it. And if you turn it sideways, you'll see that this one side's a little bit raised, and the other side is completely flat. The flat side goes down. And then there's gonna be a spacer, which is just a plain ring, doesn't matter which way you have it. And this is gonna go right on top of that. So again, the flat side is back here, the raised side comes forward. The next part you're gonna do is you're gonna have another piece, the singular ring, and again, there's a flat side and then a raised side. Have that guy facing up as well. So all the raised parts come up the part. And then lastly, you're gonna have this cover, and this one does matter. The back is flat, the front is textured. And as always, you can sand these. The sandpaper you'll want is probably around 400 grit. That would allow you to get rid of most of these sand lines. And you can also use a X-Acto knife for little strings or irregularities on the outside. Just kind of trim that off with a knife. These are printed in PETG, so there's some flex to them, and they shouldn't shatter or snap like some PLA or particularly ABS will do. Gonna grab our screw and we're gonna push it on through like that, and it's a pretty tight fit, so you will probably want to thread the screw just a little bit to get it to work its way through. There we go. You wanna make sure that you press these down enough so that the head goes a little bit into the countersunk hole on the face, just like that, so there's enough material back here for us to put a nut on after we go through and mount it to that piece. And now we can start wrapping the wire. This is 22 AUG wire, but of course you can pick whatever color wire you want, whatever thickness you want, but I would say that the thickest you'd want is probably 22, and the thinnest you would want to be about 28 AUG. Where 28 is going to be finer than that of 22. I give a little bit of extra, and then I can hold it with my thumb so that I can pull the wire tight along over the top, so that I can wrap it around and keep it really nice. Okay, here we go. So you want each loop to be right next to the other one, and no crossing of the wires in the front or the back of the part. I'm holding the wire on the front and the back to make sure it doesn't unwind as I put the next coil in. And I'm laying the final loop here. Then that's what the back looks like. So now I'm gonna pull this aside. I'm just gonna put a drop of hot glue here and here to make sure that it doesn't unravel. Expect the final product to look like this, where it's one after the other, fills up the coil, and then it's nice on the back as well. And I just drew a line of hot glue and pressed my thumb on here until it cured. Of course, my hot glue gun doesn't get super hot, so it's fine for me to do that. If yours is really hot, you're gonna wanna use a piece of wood or something else, of course. We're gonna do that for the rest of them. And there it is, all wrapped. And we've got the jig under here to put our LEDs. We can go ahead and actually put in the centerpiece, and this just goes through, line it up with the holes, and push it on through. There we go. And there. Alright, and then it comes through the back here, and there's just enough material back here for you to be able to put the nut onto, and just hand tightening those is sufficient. And you can see here that the bolt and the nut come flush when it's tightened all the way, which is perfect because you don't want these extruding too far if you're wearing this at cosplay, because that could be uncomfortable. And there you go. So you can see that it's already starting to look really nice. And so now we can go ahead and put the LEDs onto it. Now this thing does have a top and a bottom, so you want to make sure that you wire it up properly so that your wires all come off out the bottom. So the bottom is actually where the bolt lines up with the coil. coil. So you can see that neither of these work for that. Bolt to coil is gonna be the bottom. These two guys are gonna be the top. This is the bottom, and let's go ahead and wire these so that the wires come out the bottom. This is the circuit that we're doing around the edge of the reactor. So we need 10 LEDs, so we need 5 of these guys, because there's 2 LEDs here. 5 times 2 is 10. And then we've got the center LED, which is going to be 2 resistors, because we don't have another LED there to drop the voltage. These LEDs that I'm using are rated for a voltage of between 3 to 3.2 as their voltage drop, and 60 milliamps is their max. So let's assume worst case scenario here that the voltage drop of the LED is 3 volts. So that will be our highest current. And with this 56 ohm resistor, we end up with 54 milliamps, which is still below 60 milliamps, even in worst case scenario. So we're safe there. And then in this worst case scenario of 3 volt drop on the resistor at 54 milliamps, we're seeing a power of about 0.16 watts on the resistor. That's the max power that's going to be going through this resistor. So you're going to want a resistor that's a fair bit higher than this. The ones that I'm using is half watt, which is plenty enough to handle this. They only get slightly warm. And then the total current draw by this arc reactor is 330 milliamps. So that's about half of what a 9 volt can handle. 9 volts can typically take a max of 600 milliamps. And then our power here is going to be 9 volts times the total current. And so we're landing right around 3 watts for the whole system. Now I am rounding both of these up. So in practice, we should be seeing lower numbers than what's seen here. So here's one of the surface mount LEDs. You can see the little nick on the corner here, and that just means that this side is negative and this side is positive. And there's 3 individual LEDs in here, which is why there's 3 little leads on each side. We're making this like one LED, so we just solder them all together on each side. So all 3 get together, and then all 3 get together here on the positive. The circuit here is super simple. It's just 2 LEDs and a resistor, and we do that same little basic circuit 5 times around the part. Now, the way that these LEDs are wired is that the 3 positive leads are on the outside, 3 positive leads on the outside, and the 3 negative leads are on the inside, 3 negative leads on the inside. That makes it easy to wire up, keeps it simple. And if I flip this guy over, you can see that there's a little divot. That divot tells you that the pins on that side of the die are negative. So that lets me know that these 3 pins are indeed negative. So I'm going to connect the negative of the first one to the positive of the second. And I'm going to strip off a little bit at the end here. Next, we're going to decide how far out we want the resistors to go. So all the resistors will converge in one spot because we're going to have one resistor for each segment, and they should line up roughly the same so that you can consolidate them to one area under your shirt. So let's put them out just a couple inches from the part. So I'll just select my lead line to be about this long. And we can see now that the positive side comes into the LED, then it goes through, and then goes into the positive side of the next LED, which comes out to ground. And that's it for the circuit, just the resistor, these 2 LEDs. We can connect this guy up so the resistor goes to the positive side of the battery, and then the black goes to the negative side. And that's it, just do the same basic circuit 4 other times around the edge, and once more for the center, and you're done. And then for the center LED, since it's only one LED, we're just gonna have one extra resistor right after the other one, since we don't have another LED on this line. Now that the LEDs and resistors are on here, all we have to do is connect the power cable to the 9 volt battery clip, and then this end to the resistors, and then the ground to ground. It's almost finished. All we have to do is shrink these heat shrink tubings. And now, you don't have to have a heat gun. You can just use a match and keep it a good distance away, keep it moving and rotate, and you can actually get it pretty well without damaging the wire. But I do have a heat gun, so I'm gonna use that. Alright, so it looks awesome, but let's see what it looks like when we plug it in. And yeah, it looks awesome. So, these are super lightweight, and they're crazy thin. And as you can see, they're really nice and bright, which is pretty awesome because a lot of other reactors you'll see online and stuff, they're really thick and bulky. This one is so light, you could get away with just sticking it directly on a shirt and not really have it pull too bad. And again, if you want all the parts for this and don't have to worry about getting the wrong pieces or anything, just check out my Patreon and do a 1-month type subscription, and it'll give you everything you need that you saw in this video, aside from the battery. And this is what it looks like in a darker environment. And then it's obviously quite bright when I do that. And let's see, zoom, adjusting. Well, that wraps up this video, so thanks guys for watching. I hope you really enjoyed this build, and go make one yourself. So, go make some stuff.